Hello, classmates. As Group 5, we decided to take on an ambitious project that would challenge the concepts we've learned in this class and potentially have some real-world value as well. We utilized open source data from Craigslist used vehicle listings to predict and compare vehicle prices using multiple predictive models. In our presentation, we'll go through the problem we're attempting to solve, the data that we used, the analytical methodologies employed, and their interpretations to conclude by being able to recommend optimal models for accurate used vehicle pricing. It's estimated that the US used car market is more than twice the size of the new car market, and it's expected to surpass it in growth. Websites like AutoTrader, Carvana, TrueCar, and Craigslist have emerged to help buyers navigate this market to make used car purchases. While algorithms and data science undoubtedly play a part in pricing these used vehicles, prices still remain anchored on values set by the duopoly of Kelley Blue Book and the National Automobile Dealers Association, or NADA, both of which companies predate the internet. As newly equipped data scientists and car owners ourselves, we trust these companies as experts, but we want to move beyond their proprietary algorithms to develop an open source model of used car valuations on an open and digital market. Based on publicly available data for the unregulated used auto listings on Craigslist, our group will develop models to predict the organic value of vehicles when supply and demand are not anchored by the predetermined models of Kelley Blue Book and NADA. We will identify predictors by order of importance and explore the role various factors play in the used car market. Our ultimate goal is to provide a tool for buyers that will better inform a purchase price decision. Now over to Dan with some more info on the data that we used.
Thank you, Ken. So for our data, we went through the Kaggle community to obtain an open data set of Craigslist used car listings. This data is as current as January of this year. The data contains 25 predictors, over 500,000 listings, and includes vehicles from all major manufacturers. So this data provided us a pretty comprehensive look at the open used vehicle market. What is very important to our analysis is that Craigslist is an open market where sellers set their price. This is unlike closed markets such as Carvana, where selling, trading, and purchasing of used vehicles are based on prices set by the retailer, which acts essentially as an online dealership. As a result, sellers and buyers on the open market must utilize the same limited external resources, for example, Kelley Blue Book. Once we started to examine the dataset more carefully, we saw that the dataset included a material number of listings that had one or more predictors missing. To address this issue, we considered 1. Including only complete listings, that is, listings with all predictors present. 2. Excluding predictors from our analysis that were missing from a significant number of listings. And 3. Imputation based on predictive modeling or sample means. For our analysis, we elected option 1, using only listings where all predictor variables were provided. This served to simplify the dataset without influencing the price predictor or leading to any bias. After making this adjustment, we were left with a dataset containing more than 60,000 complete listings and 19 predictors. From this subset, we then created a training data subset and a testing subset, each of these subsets with about 30,000 listings. This was in order to construct a pricing model as well as to validate predictions for the open market.
Before building our models, we needed to remove predictors in the dataset that weren't relevant to us and outliers that might impact the accuracy. That included the following 6 predictors, which were relevant to Craigslist but not to us. Further, 2 numeric and eventually 1 factor predictor needed to be clipped as well. Odometer between 110 and 293,000 miles to get rid of new cars and cars that were old enough to be salvaged. Price below 175 and above 80,000 for those vehicles that were set as free erroneously and vehicles that would be considered luxury and wouldn't normally be priced. And finally, vehicles below 1975 or above 2020 for new model years that we normally wouldn't price, and vehicles older than 1975 which we consider classics and would fall under a different model. Visual plots helped our team understand our process data set better. The top graph demonstrated that individuals post their vehicles at agreeable prices to buyers, such as $9,999 instead of $10,000, as shown by the troughs. The middle graph demonstrated that certain luxury brands, such as Tesla and Porsche, retain their value much better on the used market than other luxury brands, such as Lexus and Mercedes. The bottom left graph validated for us that by removing classic cars lower than 1975 out of our data set, we have a gradual uptick in price with age, which is what we'd expect for our model. And finally, our bottom right graph demonstrates that mileage grows with age, up to a certain point at 2000 where something curious happens. As vehicles get older than that, their mileage drops, likely indicating that the vehicles available on Craigslist are ones that didn't do 12,000 miles a year and retain value because of their lower mileage.
Thank you, Sean. Hi, I'm Deb Marin, and I'm going to talk to you about the methodologies that we used for our models and how we interpreted the data. First, we had to convert some of the character values to numerical values, and we did this using a process called one-hot encoding, which assigns a numerical binary value of 1 or 0 to each factor for the presence or absence of that factor. And we put that into a new data matrix, which we used to run through 3 different models, and we did a linear regression, a recursive partition decision tree, and then we did a random forest. So the first model we ran was regression analysis. And a regression analysis tries to determine a relationship between each of the factors and the price. What we found was there was a clinarity problem with our data, and also the data set was very large. So we had to take a best subset, and to do that we had to break it down step by step because the data was too large to run a normal function in our program. What we determined was 11 variables contributed most to the variance in the price. We eliminated size as the factor that caused a clinarity problem, as it was already included in type. We came up with a mean square error of 20% of the mean, or a divergence of $5,000 in the price. So then we took another model called a recursive partition decision tree. We ran the data through this model, and the error was actually even larger, with a $7,000 divergence from the price, or 30% of the mean. The larger error produced by the decision tree model was a surprise to us. What a decision tree does is breaks the data down into subsets based on the answers to certain questions, such as, is the odometer reading greater or lesser than 80,000, yes or no? Then those new data sets are further broken down based on the answers to more questions, with the end result being a prediction in the mean price. This we really thought was going to be a better model than the regression analysis. And when it turned out not to be, we decided to run a third model called a random forest. And a random forest is a group of decision trees run over and over on different subsets of the observations. And this model produced the best result for us. With running half of the observations, 27,000 observations, we were able to predict 85% of the variance. So we decided this is the best model for us, and Sean is going to further explain how we can improve our results.
2 predictors our team discarded early was VIN and vehicle type. We didn't have an immediate way to decode a vehicle's VIN to get information, and vehicle type wasn't validated by Craigslist, resulting in errors in the data. In a future analysis, we picture using the vehicle VIN to fill in missing data for observations that we otherwise had to discard early on in our analysis. This would expand the number of observations we could use for modeling, along with making the vehicle type predictor useful for predicting that price. We feel that this would improve the accuracy significantly of our model, and we'd like to try this in the future. Pictured here, we envision using the service ClearVin to provide certain fields that we were given from the data set and retrieve the rest of the fields using their API. Team 5 concludes that yes, we can transparently provide a free model to price used vehicles on an open market like Craigslist without relying on the duopoly of Nada and Kelley Blue Book. Offered by Web, Python, or C# using an R backend in our model, we believe this is an important step to keep these open markets relevant and free in the digital age. We're used car buyers just like you, and we want to help. And we understand more than anything else when buying a used car, you want to get the best deal. Thank you.